All right, now let's go ahead with Chapter 11. This is Managing Systems Implementation. The chapter objectives are to explain the importance of software quality assurance and software engineering, describe application development using structured, object-oriented, and agile methodologies, draw a structure chart showing top-down design, modular design, cohesion, and coupling. Explain the coding process. Explain unit integration and systems testing. Differentiate between program, system operation, and user documentation. List the main steps in a systems installation and evaluation. Develop training plans for various user groups. Compare in-house and vendor training options and describe effective training techniques. Describe data conversion and changeover methods. Explain post-implementation evaluation and the final report to management. So now let's talk about software quality assurance. Companies are intensely concerned with the quality of their products and services. The main objective of quality assurance is to avoid problems or to identify them as soon as possible. Poor quality can result from inaccurate requirements, design problems, coding errors, faulty documentation, and ineffective testing. I think we all can understand what good outcomes are as it pertains to quality assurance, but let's look at some of these points here in poor quality. So inaccurate requirements, that comes from the interviewing and the surveying process, and basically that's flaws in the steps leading up to this point. Design problems, that could be something that's a fundamental flaw in the workflow that was set up. Coding errors can occur for a number of reasons. If coding is rushed to meet deadlines, if coding is sometimes handled against the will of the developer, if you don't have strong developers, or if your developers don't know the new technology that you're working with in a project. Faulty documentation, a lot of times your documentation writers really kind of reiterate what the software and system analysts discuss with them. A lot of times they don't have the understanding, which leads to faulty documentation. And of course, ineffective testing. That's either not testing enough, or that's testing things that are not relevant to the major workflow. Let's talk about software engineering. A software development process that stresses solid design, accurate documentation, and careful testing. One thing I would add to that is a software engineer should do a preliminary test on their own development, but there should always be a quality assurance group. It's not okay to have your software engineer do their own testing. They can catch the big stuff, but they aren't going to be able to think outside the box because they're focused on what they've been doing. The Software Engineering Institute at Carnegie Mellon University, or the SEI, they've designed software development standards used successfully by thousands of organizations around the globe. The Capability Maturity Model, or CMM, improves software quality, reduces development time, and cuts costs. New model integrates software and systems development into a much larger framework called process improvement, and that is known as the Capability Maturity Model Integration, or CMMI. We'll be going through that a little bit more later on. And here is CMMI. So these are the 5 different levels of maturity that can be discussed and managed through CMMI. The International Organization for Standards, or the ISO. So you've all heard of organizations such as ISO 9000. Growing up around Flint, there was always the ISO 9000 and the ISO 9002 certifications, which both the UAW and General Motors looked to really hard to maintain those standards. That meant that everything was done in a uniform fashion, and it had a solid plan and solid development life cycle that was associated with it. So ISO is a worldwide body that establishes quality standards for products and services. ISO standards include everything from internationally recognized symbols to the ISBN numbering system. And I have the ISBN number for this textbook, which many of you might have Googled to purchase it. Now we'll go through the overview of application development. Application development is the process of constructing the programs and the code modules that serve as the building blocks of the information system. Structured analysis, object-oriented analysis, and agile methodologies are three popular development options. The objective is to translate the design into a program and code that into code modules that will function properly. So a lot of these terms are concepts that we've gone throughout the course. I'm going to let you take a minute and look this over. We've covered all of this up until this point, like I said. Now let's continue the overview of application development by going through some of the application development tasks. In the traditional method, we like to develop an overall strategy, design, code, and test, and document individual modules. A module consists of related program code organized into small units that are easy to understand and maintain. Some of the modules that we have within our student information system here at Albertus would be the financial aid module. There's the accounts receivable module. There's the registration module. They are usually broken down by business unit or department. Continuing on, Agile methods create a system through an interactive process of planning, designing, coding, and testing. Examples include the spiral model and the extreme programming model. So right here is a very simplified version of the extreme programming model. System development tools. We've gone over the ERDs, or the entity relationship diagrams. We've gone over flow charting, and we have gone over pseudocoding again. We've also discussed decision tables and decision trees, and we've also discussed how this applies in project management. Structured charts show the program modules and the relationships among them. When we're designing this, we have a module, which is a rectangle that represents the module. Vertical lines at the edges of the rectangle indicate that a module is a library module. Reusable code can be invoked from more than one point in the chart. A data couple is an arrow with an empty circle. It represents a data couple, which shows data that one module passes to another. The control couple, an arrow with a filled circle, represents a control couple, which shows a message, also called a status flag, which one module sends to the other. And then of course there's a condition, which is represented by the diamond, which can usually answer questions like A or B or yes or no. And then there's a loop, which is a curved arrow that represents which indicates that a module can be repeated until a certain condition is met. So in this example here, produce grade reports. It could continue on to do this for each student as it goes through and grades everybody's work. Continuing on, cohesion and coupling. Cohesion measures a module's scope and processing characteristics. A module that performs a single function or task has a high degree of cohesion, which is desirable because it focuses on the single task and it's much easier to code and to reuse. So check customer number and credit limit as opposed to check customer number. It can be used as for much more wide range of purposes, and also if you split it up here. Here's an example of a tightly coupled and loosely coupled structure chart. Now, when we go into drawing a structure chart, you follow 4 steps. Review DFDs to identify the processes and methods. Identify the program modules and determine the control subordinate relationships. Add symbols for couples and loops. Analyze the structure chart and data dictionary to ensure that it is consistent with your system documentation. And here is an example of a structured chart based on the order system. And if you look on page 196 through 198, you'll see the example in your textbook. Let's continue on by discussing object-oriented application development. Characteristics of object-oriented application development. Individual object instances belong to classes of objects with similar characteristics. The relationship and intersection among classes are described using a class diagram. Class diagrams describe the characteristics of objects in a class and the methods which represent the logic. Now we'll continue on with agile application development. And I'll let you go ahead and read this slide for yourselves here. This goes over extreme programming. An extreme programming example. The first step in the extreme programming process, like any other development method, would be to define the system requirements. The customer begins by meeting with programmers and by providing user stories, which are short, simple requirements definitions, and they can be presented in an actual story form about what the user does and what they need. Programmers review user stories to determine the project requirements, priorities, and scope. User stories do not deal with technical details. Like I said, they're stories, they're short, and they give a specific story about a task that the user must perform on a regular basis. The programming team regularly meets with the customer, who tests prototype releases as they become available. So they continually develop, test, develop, user test. Extreme programming uses parallel programming, where 2 programmers work on the same task on the same computer. So it's like a team of 2 people. One drives or programs while the other navigates. The onlooker can examine the code strategically to see what's going on the other person's driving through. It's kind of like having a co-pilot on an airplane. So let's discuss its future. It's becoming very popular for projects, and it's got supporters and it's also got detractors. The supporters, boasts that it speeds up software development and delivers precisely what the customer wants when the customer wants it, while fostering teamwork and empowering all employees. The critics will say that it lacks discipline and produces systems of questionable quality and may not work well for larger projects because of their complexity and the lack of focus on the well-defined end product. Like I've been pretty clear about throughout this course, I am a critic. I've seen it work very badly. I've seen it done on a larger project like an ERP system where certain elements just don't have to work with others. So I am, like I said, we've probably at this point had the guest speaker in. So let's talk about coding. Programming environments include Visual Basic, Python, Ruby on Rails, and SQL Server Management Studio would be examples of commonly used programming languages. Internet-based applications such as HTML, XML, Java, and other web-centric languages are also useful. An integrated development or an IDE environment or an IDE makes it easier to program interactive software by built-in tools and advanced features such as real-time error detection, syntax hints, and highlighted code. The biggest example of the IDE I can think of right now would be Visual Studio, which includes Visual C++, Visual Basic, and Visual C#, what have you. So it practically tells you how to write the code if anyone's ever worked it. It's very powerful and it's a very nice interface. Application generators, report writers, and screen generators and fourth generation languages exist. Like I said, when you're generating code with application generators and screen generators, the behind the scenes code is very, very messy, most likely, because it is put together by a machine and it's not designed to be user readable. So when dealing with application generated code, you want to stick to the code and you want to stick to the environment where the code is generated. Let's talk about testing. Each program must be tested to make sure it functions correctly. That includes desk checking. Groups of 3 to 5 IT staff members participate in code review. That's important. So desk checking is to have somebody at the desk test it to make sure that it works, as just a general quick overview. And continuing on, unit testing of an individual program or module. Its objective is to identify and eliminate execution errors that could cause the program to terminate abnormally and logic errors that could have been missed during desk checking. Unit testing also involves test data, and it should contain both correct and erroneous data, so you want to try and catch all possible situations as they occur. And like I said, there should be an actual QA group that sets this up. Programs that interact with other programs and files are tested individually before they are integrated into the system, so as an individual unit. Somebody other than the programmer who wrote the program usually creates the test data and reviews the results. I have been saying this quite a bit here. A programmer or a system engineer cannot test their own work. It doesn't work. Integration testing. That's the testing of 2 or more programs that depend on each other to make sure that they function together properly. Finally, system testing involves performing the final test of all programs. You verify that the system will handle valid and invalid data properly. You ensure that the IT staff has the documentation and instructions needed to operate the system properly, and that the backup and restart capabilities of the system are adequate. You demonstrate that users can interact with the system successfully. You verify that the system components are integrated properly and that actual processing situations can be handled correctly. You confirm that the information system can handle predicted volumes of data in a timely and efficient manner. You want to take care of all the systems testing ahead of time, because if your system isn't able to handle this data and handle all of this, I know I've said it already in this class, but you've got a situation very similar to the Obamacare rollout, and that would be horrible. Now let's go through documentation. Program documentation. Program documentation describes the inputs, outputs, and processing logic for all program modules. Process starts in the systems analysis phase and continues during the systems implementation. So documentation from start to finish is what we're saying. Systems analysts prepare overall documentation such as process descriptions and report layouts, and this is early on in the systems development lifecycle process. This documentation guides programmers who construct modules that are well supported by internal and external comments and descriptions that can be understood and maintained very easily. System documentation describes the system's functions and how they are implemented. This includes data dictionary entries, data flow diagrams, or DFDs, object models, the layout of the screen, source documents, and the system's requests that initiated the project. So basically you want to take everything that started and from start to finish with the project and put it together and try and keep it as chronological as possible, but you also want to organize it by what it is. Operational documentation contains all of the information needed for processing and distributing online and printed output. So this is how you use the system and how it functions. User documentation consists of specific instructions and information to users who will interact with the systems, and it includes the manuals, help screens, and the tutorials. So this is usually going to be some of the more complex and larger pieces of documentation because it'll include instructions and information for every screen, for every field, for every feature. And it's stuff that everyday end users will take care of and use. User documentation is a system, continuing on I should say, is a system overview that clearly describes all major system features, capabilities, and limitations. It's a description of source document content, preparation, processing, and samples. It's an overview of menu and data entry screen options, content, and processing instructions, and like I said, that's on a screen by screen basis and module by module basis. It has examples of reports that are produced regularly or available at the user's requests, and there's going to be samples including sample data. Security and audit trail information will be included in the user documentation. These are logs of what's been done and how security is managed. There's going to be an explanation of responsibility for specific input, output, or processing requirements. So there's going to be specific instructions saying this person has this role and this is the function of this role. I've noticed that during these implementations to make user permission and user security role-based rather than user-based is the way to go. Procedures for requesting changes and reporting problems. Examples of exceptions and error situations. You're going to want an FAQ section, and you're going to want an explanation on how to get help and procedures for updating the manual. This manual is going to be excellent, but it won't be perfect, so you will need a procedure for making changes and updates as the system grows and develops. Here's a sample page from a user manual. Let's talk about manager approval. After system testing is complete, you present the results to management. You should describe the test results, update the status of all required documentation, and summarize input from users who participated in the system testing. So give management what they need to see to validate everything. You must also provide a detailed timeline, cost estimates, and you need to discuss staffing for making the system fully operational. Like I said, in IT, a lot of times not all staff members have equal skills. System installation and evaluation. Prepare a separate operational and test environment. I've actually seen up to 4 environments. There's the sandbox or the development environment. Then you would have the test environment. Then you would have a user acceptance testing or UAT environment. And then you'd have your production environment. So I've seen as many as 4 and I've seen as few as 2, but you always want to have a test environment at least. Provide training for users, managers, and IT staff. Perform data conversion and system changeover. Carry out a post-implementation evaluation of the system and present a final report to management. Operational and test environments. An environment for the actual system is called the operational or production environment. I've always heard it referred to as the production environment. The environment that analysts and programmers use to develop and maintain programs is called the test environment. A separate test environment is necessary to maintain system security and integrity and protect the operational environment. So there's development environments, test environments. Those are low-level environments. Like I said, I've seen up to 4 of these, 4 different environments, and we're going to see an example on the next slide here. So access to operational environment is limited to users and it must be strictly controlled. So when it comes to training, we need to go over having a training plan. It's essential to provide the right training for the right people at the right time. The programmers are going to have a really good idea of what goes where, and they're going to have an idea based on the work that they've done with the different end users. So they need to understand that a training plan is going to need to be put in place. The first step is to identify who should receive the training and what training is needed. So when you're doing this, you need to look at the organization and how the system will support the business operations and who is going to be most affected and involved. And a lot of times that's going to be the operational employees because they're the ones who are hitting the system the hardest. So here's some examples of some different training topics to go over for people wearing different hats within the organization. Training also involves vendor training, and some of that might be requests for proposal, requests for quotation. The vendors are going to need to know how to do that in a new system. So that needs to be something that we look at. There's webinars, podcasts, and tutorials. Many vendors offer web-based training options, including webinars, podcasts, and tutorials. I'm working with a system called Sugar CRM right now. They do this sort of thing all the time. And outside training should also be available. So a couple training tips. Interactive training. Most people prefer hands-on. I think a lot of people probably don't like this class because it doesn't seem super hands-on, but wait till weeks 7 and 8, you'll see a little bit more there. But I think a lot of people respond to hands-on training. And it's less expensive, and it can involve training manuals, printed handouts, and online materials. Train people in groups. Select the most effective place for training, some place that's comfortable, and rely on previous trainees. Continuing on with online training, so it doesn't matter what the instructional method. Lessons should include step-by-step instructions for using the features of the system, whether it's online or not, and the training materials need to be as realistic as possible. That's for online training, that's for any type of training. There's also video tutorials that you might consider, and CBTs. So here's a sample of what a training slide might look like. This is an example of a training tool. I'm not going to worry about that too much. Data conversion strategies. When a new system replaces an existing system, you should automate the data conversion process. The old system might be capable of exporting data in acceptable format for the new system. So you might try connecting using ODBC, which stands for Open Database Connectivity. It's an industry standard protocol that allows databases from different vendors to interact and communicate. There's also middleware, which is unfortunately what gets used more often than not, but it connects products that aren't similar at all and enables them to communicate. Sometimes middleware is extremely simple, sometimes it's extremely complex, but it's always a good option. A lot of times it's written in-house. Data conversion security and controls. Maintain strict input controls during the conversion process. A lot of times when you're working with the SQL database, it does highly limit what you're able to enter and stuff. Consider using pull downs. Less error prone data is better. Ensure that all system control measures are in place and operational to protect data from unauthorized access and to help prevent erroneous input. And kind of what we just said. System changeover is the process of putting the new information system online and retiring the old system. Changeover can be rapid or slow depending on the method. So the 4 changeover methods are the direct cutover. That's where you cut over everything at once, start using the new system, stop using the old. There's parallel operation, which is where you actually use both systems and enter the data twice at the same time into both systems. There's the pilot operation, which is usually the least expensive. It's where you do a little pilot test launch. And then there's phased operation, where you slowly take different modules or different pieces of the old application and integrate it and cut it over into the new application. I think the direct cutover way is the safest way to go. It's also the most, well, I was going to say it's the safest, but it's also the most risky. I was going to say it's the quickest, but it's also the most risky. So direct cutover, basically what I just said here, you stop using the old, you start using the new. It's the least expensive, but it's got a lot of risk involved. You've got the parallel operation where users will use both systems at the same time. And then you've got the pilot operation where the old system gets slowly implemented with just a small piece and then everything else. And then there's the phased cutover. And here are the different slides basically going through what we just said. I like the system changeover chart here. This really kind of shows the cost as it's associated with the risk. Remember I said earlier that the direct cutover is extremely risky, but it's the least expensive. That's kind of what I meant by this. So this shows the different risk levels associated with cost. So obviously the parallel operation is the lowest risk, but it's also very costly because work cannot get done quickly. Let's go over post-implementation tasks, specifically the post-implementation evaluation. A post-implementation evaluation assesses the overall quality of the information system. We go through accuracy, completeness, timeliness of the information system output. We go through user satisfaction. How well does the system respond? How easy is it to use? Is it reliable? Is it maintainable? This takes a couple weeks to determine this. Sometimes it can take months depending on what external outputs are required. Adequacy of system controls and security. Again, that's something that you want to check over a little bit of time, but you want to know right away if it's fairly decent. Hardware efficiency and platform performance. Effectiveness of database implementation. The performance of the IT staff. And finally, the completeness and quality of the documentation. Quality and effectiveness of training. Accuracy of cost-benefit estimates and development schedules. So when you're evaluating the system, you should interview members of management and key users, observe users and computer operations personnel actually working with the new system. So management by walking around, excellent concept. Read all documentation and training materials. Examine all source documents, output reports, and screen displays. So look for problems with yourself. And then finally use questionnaires and surveys to see how things are going. Conduct reports from your help desk. See what kind of problems users are having. Look for patterns and correlations there. Here's a sample of a user evaluation form where they can go ahead and rate the new system. So then, after all that's said and done, then you present the final report to management. And that's at the end of each systems development lifecycle phase. So this is the final phase. You're going to submit, or it's not the final phase, but you're going to submit to management. This report should include the following: the final version of all system documentation, any kind of planned modifications, a recap of all systems development costs and schedules, a comparison of actual costs and schedules to the original estimates, and include the evaluation if one has been done. In these next couple slides, I'm going to go through the summary. I'm going to let you review that quietly. Thank you very much.